Alright, so continuing working on the stuff that I was working on yesterday, trying to make my AI smarter, especially when they get trapped in stuff. And basically, up until now, I've had them flying around kind of big asteroids and stuff, and generally they don't get caught in those things. The avoidance behavior can get them to kind of jiggle around a asteroid and then get them flying free again. And then generally they're just trying to track the player. So if the player's not always like on top of an asteroid, they don't get stuck too often, or on the directly other side of the asteroid and things like that. But some of my mission ideas involve big kind of structures that somewhat flat, like walls, like really big ships and things like that. And then also the big ships have tunnels and things like that. So this AI would be better if they could navigate those tunnels. The game would be a lot more fun if I could get them to chase the player through the tunnels and stuff. So, but even just on the outside stuff, I found they're having a hard time weaving in and out of complex ship-type geometry. So that's going to be a problem, especially when we have like space stations and other things. So I'm creating kind of a way where if it comes across a wall and it's not going to be able to go left or right or something like that, it kind of starts to do sort of a searching or probing with raycasts. So if it's open forward, they'll just go forward. If it's just a little off to the left or a little off to the right, they'll just kind of dodge and go around, which will be good for smaller debris fields or ships and things like that. But if there's just like a big block in front of them, they're going to start to use raycasts to go like 30 degrees this way, 30 degrees that way, 30 degrees up, 30 degrees down, and kind of create things. So what I have here is a raycast that is going to go, I think it's like a 45-degree angle or something like that. So you'll see a gray box, and I have it set so that my game will pause. So, all right. So what happened here was you've got these are your left, right, and center things. If these things are all hitting a wall, so they're going, okay, we're stuck. And then up here, I created a prefab of just a ball. It's a ball of lightning, but and you can see I have it set so that it will. I'll just move that prefab to the point where this gray line goes to. So what that's doing is it basically sent out another feeler at a 45-degree angle, and I could have done a 30. So my idea is that I'll have like a 30-degree angle and see if I can just like pop over the top of something. Maybe it's short, but directly in front of me it's a wall, but it's not that. If I go up a little bit, it will go over. So if that doesn't work, you can do a 45-degree angle. It's a little bit more dramatic, as you can see. So the ship would have to rotate to aim at that. So I don't know, if you're a Unity programmer and maybe not the best vector math or quaternion person who didn't do so hot in college math and maybe doesn't have a technical degree like that in computer programming or math, you probably are with me that rotations can be very confusing. So I eventually figured out how to get my guy to look at that. And one of the reasons why it's more complicated is that there is a look at feature for Unity, but I have my ships rotate at certain speeds, so like fighters rotate faster than others, but I don't want it to be instant. A giant capital ship is going to slowly rotate around. So a look at feature a lot of times is just too fast, and it's not easy to like set up and dial in like how many degrees a second should it rotate. So my ships actually have a degrees per second rotation, so that I can really kind of fine tune how how long it should take a ship to turn around and stuff like that. So the code got a little bit more complicated, trying to figure out, okay, well, how do I find the position of this, and then how do I set up the degrees to rotate and things like that. So I just had to use some, I think I ended up using an inverse transform at one point, and then adding the vector of this out here in space to the player transform. Make sure it's in local coordinates, essentially. Maybe it was transform point. Anyway, so you'll see if I unpause, it'll rotate right up. And now, so I've taken off the movement so that he can't move right now. So you'll see that vector, that raycast now is like going this way, but that's not, we don't need that right now because we've got a free path forward. So once the ship dials in that this is something that's free to go to, it's going to just go straight up to it, and then it would then recheck its its target. So and we could set it up so that it's pinging like directly towards the target, so that as it's flying up, it could say, okay, am I over the wall, am I over the wall, am I over the wall? Okay, when it gets to about here, it's over the wall, and it could stop. It doesn't have to go all the way to the end of this raycast. That's just the length of the avoidance information, so it's not a big deal. Yeah, so that's what this is doing, and so my idea is that I would have a few search algorithms like that. So there'd be one for a 30 and one for a 45. There would also be some that go out to the right and to the left, so that something might be able to go around it to the right or to the left, but just in a more extreme way than the short changes in direction. And so I think that's what I was finding was that if it's really a big surface, then they get kind of caught up on those big surfaces, and they need kind of a smarter way to do it, more looking around. Like the pilot should be looking around at what's going on. So I think these raycasts are kind of the way to do it. I think this should allow the ships to go through tunnels and things like that, or through small spaces in big structures. And then the final thing I'm going to have to do is set up a way for if it pings all these areas kind of in front of it and it finds that it's blocked in all those different ways, I think it should just assume that it's in trouble and it needs to turn around and then start searching for an alternative route. And so what I would do with that is, I don't know, I need to flag some way, like this position is kind of a dead end, and the ship would have to remember that, and then it would just turn around and head back out in the direction that it was going, and maybe try to find another way to turn as it's backtracking. So maybe there's a turn that it can go to get around something and get out. So I guess part of it is hopefully nothing is so complex that there's lots of dead ends, but in the tunnel scenario, that would be a problem. So they would have to try to turn around and get out again. And this is all doing it dynamically rather than creating like waypoints for AI guidance. And maybe that would be an easier way to do it. But so we'll have to see how much CPU this uses, I guess, as well, since there's gonna be a lot of ships kind of using this navigation, and then a way to basically, as soon as they find a solution, just cut off the raycasting, so it doesn't it doesn't have to raycast like 20 times a turn, and as soon as it finds a solution that's good enough, that it can just go, So anyway, so you can see it again. Just aims at that, and then it will turn and go to it, and then it would actually be moving while it's turning, but it would go up and over that wall, and then as soon as it's over, it would say, "Oh wait, I'm clear of that obstacle. Let's go." let's go straight again. Yeah. So that is that. The code is very messy right now. But the basic idea is right here. And I used to have one just like, I don't know, the rotations were all a mess, so this really does rotate. So it says if the right or left is blocked, then we want the raycast for the rotated vector. And actually, I'm getting that way up. Yeah, I did that up here. I just didn't move it down, but I would definitely move it later. Where is it? So here is, no. Here's my rotated vector stuff. So you rotate, if you want to rotate a vector, you have to use quaternion angle axis. And so this is a 45-degree turning on that right axis. So it's turning the nose up and down, and then multiply it by the transform forward, and that gives you a rotated 45-degree arrow pointing 45-degree angle. And then you can draw that ray, so that's that gray ray. Basically, it's just taking that rotated vector, multiplying it by the avoidance, which is like 500 or something. And then once it uses this rotated vector to actually throw a raycast out, and that's what it was doing over here. Basically, it goes through the cycle. Left and right are blocked, but you can go up. So it will throw this vector, this raycast, the rotated vector, so it's checking for that 45-degree angle. If there's a 45-degree angle, then we're going to use it. And so if this, and you see this is negative, so it says if we didn't hit anything. So before we're actually checking to see if we hit anything, and here we're actually checking to see that we didn't hit anything. That means the route's clear. This kind of waypoint that we're generating is clear. That's what we want. So, and if that's clear, then this is just for my prefab. But I originally was thinking maybe I need to have a temporary target for it to go to before it goes to the real target, but I'm not sure I need that yet, but I'm keeping it in there. And then so that's why it's moving this target sphere. But so I might not need the temp target. It just uses this heading. So the heading is just the temp target value, which is the transform position added to the rotated vector times the avoidance. So this is just basically that ray that we cast. And then we're adding it to the transform position, and that gives us where this thing is, above us and forward. That's the actual positioning, and then relative to the player. And then so the desired heading is that position minus the transform position. That will give us a direction vector. And once we have that, then we can rotate towards it. And I also have this turning true so that it will make the turn without trying to use any of the other avoidance behaviors again, because now we have a clear path. We don't need to avoid the wall. We've already decided how we're going to avoid the wall. So as the new thing before, I just kept running the collision avoidance over and over and over again. It makes it very jittery. I think this will be better. You've got something to look at. You know it's clear, and you can just go. So kind of turn off avoidance. I'm sure there's a better way to do this, but right now it's hacked together that way. So this is the code that I'm going to do like some sort of searching algorithm, maybe a for loop or something like that, kind of iterating through different vectors in different directions at different angles. And then once the collision avoidance returns, and so the turning thing will if it's turning, return. Don't do any more collision avoidance. And then so after you do that, it takes the desired heading and it makes a rotation goal from the look rotation desired heading. And so the goal is what we want to turn to. We want our rotation to match that. Since we don't want to do it super fast, we need it to be a goal in the future. And we're not using SLERP, we're using rotate towards. I found this to be more accurate, and I can give it an amount of degrees. So if you look, it's you need a quaternion from and a quaternion to, and then a max degree change. By doing that, you can create a number of degrees per second and then multiply it by time delta time, and that will make it turn that many degrees per second on with the frame rate. So so you just start at your rotation, you have your rotation goal, and then if you're turning at 90 degrees a second, then that would go here, but then you multiply it by the delta time, and that reduces it to whatever increment it needs to move in that split of a second, however many, 60th of a second or whatever. And this was just for me to make sure that everything was matching up what my heading was, and I just wanted to see it in a global variable. So I'll delete that someday. Yeah, so that's how that works. Someday I should just do like a real tutorial from this. Some of this stuff I definitely learned from other people, but I think, I don't know, my method is working for me, so hopefully this is interesting to people who are dealing with the same problem. All right, and this stuff is part of the behavior behavior designer, so that's why it's within a task. So yeah, anyway, that's that. I'm gonna cut off this video now.